Alright guys, welcome back to Physics Tutoring for Mods. And if you watched my last video, you remember that we went over the big five kinematic equations. And those equations are going to play directly into what we call projectile motion. Okay? Now, what is projectile motion? Projectile motion is composed of two parts, horizontal motion and vertical motion. Projectiles are defined as objects that are only acted on by the force of gravity. So for example, if I threw my ball up here, the only force acting on my ball, if you ignore air resistance because that's pretty small, is what force? Gravity, right? Similarly, projectiles are defined by their key characteristics, that gravity is the only force acting on them. Okay? Now, let's move on to horizontal motion, which is one component of projectile motion. So, if you throw a ball, right? If you throw a ball, you know that the ball is going to have a curved arc, most likely. Otherwise, if you threw it straight, then it would probably be different, right? But most likely, it's going to be a curved arc. Now, the curved arc, obviously, the force acting on the ball is gravity, right? But in which direction is gravity? In down direction. So gravity is a vertical changer, okay? It changes the vertical quantity of the ball. But what about the horizontal velocity? Does the horizontal velocity change at all? No, right? There's no force acting against the horizontal velocity. Gravity only acts against the vertical velocity and the vertical motion. But horizontal motion isn't hindered or helped by any force. Only the force you give it at the start, right? And then air resistance, we can ignore that because it's pretty small. So the ball has only horizontal and vertical, but vertical has G hindering it, but horizontal has no force. That's why the velocity is going to stay the same across its time of flight. Okay? That's what you want to remember. For X, it's pretty easy. The velocity just stays the same over the time of flight. And it looks something like this. H is equal to Hsi plus Vxt, which makes sense, right? If you might be more used to this, Hf. So then you probably recognize this equation, the position time equation. And this is very similar. It's the same equation we use for projectile motion. Hf is just going to be Hsi plus Vxt. But over here, remember, this is Vxt. That's the only change here. Because we have two velocities. If I throw the ball like this, right, at a curved arc, and if I take a bunch of different colors, let me say red represents x, so that's the horizontal vector, and pink represents y. That's the vertical vector. Each vector is going to have a horizontal and a vertical force to it, right? A horizontal and a vertical velocity. And this represents, so the pink one is a vertical velocity, the horizontal one is a red velocity. And this is the only one we're looking at. Okay? And you know how to calculate that, right? If you're given at an angle, you know that's just going to be that the force or the velocity initial, right? What the velocity vector is, what speed it's drawn at, that velocity initial times cosine of theta is your Vx. These equations should look familiar. If they're not, you should check out my other videos on vectors. Okay? So like I said, there is no acceleration in x for basic projectile motion. This 1/2 at squared doesn't matter. So, I mean, if you look at the first one of the big five equation, Hf is equal to Hsi plus Vit plus 1/2 at squared. Since we know that a is 0, we can just cancel out this entire term because there's no acceleration. It stays at the same velocity. In order for there need to be acceleration, if you remember F equals ma, Newton's second law, there needs to be a force. And there is no force, right? You start off with a force, but that force isn't retained throughout its time of being. the force just starts off and then it stays in motion. The force is only at the point in time you throw it. After that, it doesn't affect anything. So this term would be cancelled and you'll be left with this. But for the y, it's going to be a bit different, which we'll look at later. Okay? So let's say there's a table. Just a quick practice question. Right? So there's a table. And the ball rolls off this table. It leaves it at horizontally at 6 meters per second, okay? So you can assume the path of flight for the ball is going to be something that looks like this, right? It starts at the table, but then it's going to slowly go down in a parabolic path. If I draw using the same vectors, red is going to be vector x, vx. It's going to go horizontally to the right? So it's going to go that way. Then pink is going to be vy. It's going down, so it's going to go just down. Now vx is the horizontal vector, so we need to keep that in mind. It lands 0.9 meters below the tabletop. So 0.9 meters below the tabletop. Write x of t and explain why vx equals 6 meters per second always, even just before the landing. So that means xf is equal to x initial. So x initial we can say is that, oh, whoops, what are all those dots? Yeah, we can say x initial is 0 because it starts over here, right? And then it goes down. And vx is equal to 6 meters per second. So if you remember, right, we start over here for our x and we keep going this way. It's not the y, so it wouldn't be negative. It's just that we start over here and we keep going this way. So it would have a positive value. If I consider that this table is a starting point or 0, then it makes sense how velocity x will just carry it along the way. So I consider this as 0. And then what's vx? Well, they gave it to us here, right? We didn't need to calculate it. Thank God, but we might need to later. So keep in mind the cosine formula. Vx is equal to 6 meters per second. So instead of Vx, I put 6 meters per second. And then what else? Vx t, right? So I substitute in t. So this just becomes, if you want to ignore units, you can say 6t. But always remember the units are there, right? Otherwise it doesn't make sense because this is s and then this becomes 6 seconds. And then the units don't match it for the xf. And even right before landing, the vx is going to be what? It's going to be 6 meters per second. The velocity carries on throughout because there's nothing stopping it in the x direction. Only gravity, right? Once it hits the floor, then it's hindered. But until then, as it is a projectile, where the only force acting on it is gravity, nothing hits it, so its velocity is constant. And the velocity final, or velocity x final, is always equal to velocity x initial, which means it starts with the same velocity and ends with the same velocity. It doesn't change. But we'll see how that can be different for y. Now let's try some horizontal motion problems. As always, I'll have more detailed problems on artslearning.com as well as a PDF and a video regarding these questions that I'll be pushing out later on. But for now, just pause the video and have a go at it. Alright, let's try it out together. A rock is thrown horizontally at 8 meters per second off a cliff. So I'm over here and then I throw the rock. Write the horizontal position equation. So we know that's going to look something like xf is equal to xi plus vt, vxt. X is equal to, xi is initial. I can say that this starts at 0 meters, plus vx horizontally at 8 meters per second times t. T is, well, we don't need t, right? They're just asking us to write the general equation. So h is equal to 8t. So what that means is the only velocity this gains is not from you throwing it. So if you throw it vertically, then it gains some velocity vertical, right? But if you just throw it horizontally, if you just chuck it straight horizontally, then it does curve down, but that's from gravity. You don't give it any velocity or y velocity or any y movement, okay? So the next question is a ball launches at 20 meters per second, 30 degrees above the horizontal. So the horizontal x-axis is here, 30 degrees, and the vector magnitude is 20 meters per second. Find Vx, then write x of t. Vx, like I told you, is going to be 20 meters per second times cosine of 30 degrees. Because, I mean, I went over it in vector math, right? The x vector is always the cosine of the angle times the magnitude. You can look over that if you need more help on this. Okay, so then cosine of 30 is root 3 over 2. So this would be 10 root 3. Of course, you can simplify it with the calculator, but I'm just going to leave it like this for now, okay? So this is Vx, and then obviously meter per second. So x of t, or just x, would be x initial, or 0, if I count it as it starts at 0. And then plus Vx, or 10 root 3, meter per second, times t. Easy, right? So the 0 can cancel out, and it can be just left with this. Yeah. So you can remove that meter per second if it's confusing you, but always remember that those are the units of the velocity there. A projectile's horizontal velocity decreases the longer it's in the air. True or false? Justify. Like I said, right? A projectile's horizontal velocity is not changed at all. Because for y velocity, what's the force acting on it? The force being pulled back down is gravity, right? But for horizontal, there's no force acting on it. It's only the force you throw, and then it just contains that force. Objects in motion stay in motion, right? Newton's first law. So it doesn't matter how long it stays in air. It's still going to have the same horizontal velocity. Only when it comes into contact with something, or if there's a force pushing back on it in the x direction, is it going to change the duration or the velocity. Okay? And also, in general, the balls falling only have something to do with the y. Okay? Because the y is the one that curves them down and makes them hit the ground. The x never really changes that. It just keeps going in the x direction. Unless you hit something in the x direction, which is, you might hit like the wall or something, if you're throwing it directly at a wall. But otherwise, it's just keep in mind, in general, it's the y that's the problem causer. See here, right? AT. 17.3 is just the 20 cosine 30, or 10 root 3. And then, yeah, no horizontal force acts. Now for vertical motion, let's use one of the big five. Okay? So let's just say, for this big five equation, let's just practice, right? Let's just incorporate some of that as well. For this big five, I wanted an equation that gives me y position, okay? That gives me position, given an initial position, an initial velocity, no final velocity though, and acceleration, as well as time. It doesn't have velocity final, but I want y final. How do I get that? Well, this equation from the big five. Okay? But we're going to slightly tweak this equation. instead of vi here, it's just going to be vi comma y, which means the velocity initial but in the y direction, because we don't care about the x direction. That's not going to have an impact in the y direction, right? And then plus 1/2 gt squared. Whoops, I already kind of tweaked it here. But imagine this was at squared, right? Then the force of gravity, as we know, is negative 9.81 meter per second squared. So we just put down 1/2 negative, so negative 1/2 g. And then you can represent g as a positive, okay? It's just a positive 9.81 meter per second squared, because motion is always in the downward horizontal direction. Sorry, downwards vertical direction. So let's go over it. So a big jump from horizontal motion. This has 3 equations, okay? This one is just one I just showed you. Y final is equal to y initial plus vy I. So this, you can put a comma if you need to, okay? This just means the velocity initial, but in the y direction. So you'd probably do velocity initial times sine theta. So this is probably vi sine theta. This is also another way you can represent it. Instead of saying vyi, you can just say yi plus vi sine theta. Okay? And then minus 1/2 gt squared. That's plus 1/2 at squared, but since g is acting in the negative direction, we do minus 1/2 gt squared. Okay? Now, that's for position. Now let's look at vy final. That's the velocity initial in the y direction minus gt. Does that make sense? Well, if you remember the velocity equation from the big 5, velocity final is equal to velocity initial plus a times t. If acceleration, so we can just plug in acceleration here, right? We know that's negative g times t. The velocity initial, we know that's viy, or you can also write it as vi sine theta. And then we can just say that v final in the y direction is this, viy minus gt. That makes sense, right? You start with an initial velocity, but then what happens? Every second, gravity removes that by 9.81, by 9.81, by 9.81, continuously like that, okay? And then the final one, which is just also a substitution of one of the big 5 equations. That's why they're so fundamental for projectile motion. Vf squared is equal to vi squared plus 2a delta x. Here it's going to be delta y because it's in the delta y direction. 2a, we know that's 2g, and it's going to be negative 2g because it's in the downward direction. Vi is viy, or vi sine theta squared, or you could just write viy for now. And then velocity final in the y direction squared is this thing squared minus 2g delta y. So yeah, only the a changes and the vyi becomes vi sine theta. You can represent it like that. So these are the new projectile motion. These are not per se new equations. It's just you need to know how to plug in a equals negative g to these equations to get vertical motion formulas. Let's work through an example. And this time we'll be going over the more easier versions, okay? I'll be pushing out more videos where I have harder versions, because obviously the goal of this channel is to get you into a test prepared for every possible scenario. And that's what we're going to do. A ball is thrown straight up, so with projectile motion it definitely helps to draw the diagram, at 14 meters per second. So actually, let me use a bigger graph here. Might take some space, but let me go here. Okay. It's a 14 meters per second. A bit hard to read, but it's fine. Take up equals positive, g equals 9.8 meters per second squared. Okay, that means up is the positive direction and down is the negative direction. Find the time to reach maximum height and the height itself. Okay. So That means parabolic curve. Okay? What's the time with the maximum height? That's going to be over here. Okay? And how do we get that? From the y position equation. How do we get that? Well, it's not that hard. We just have to realize that velocity x here is the only velocity contributing. Velocity y at this point is 0. Do you know why velocity y is 0? Because over here you have positive velocity. At some time, positive velocity has to hit 0 to then become negative velocity, right? It has to cross the 0 threshold to then become negative. And that place is this vertex, because if you draw a horizontal line to find the slope at the vertex, you can see it's approximately 0, right? Which means that there's no vertical velocity at that point. You still have acceleration, but no velocity. Okay? Now we're going to use Vy is equal to Vi y initial minus gt. So we know Vy has to be what? 0, because I just showed you, right? It has to be 0 meter per second at this point. Vyi is 14. So they didn't give us they didn't say at an angle. So we can just use 14 meter per second. Okay, because it's just thrown straight up. So this diagram is a bit misleading, but it looks more like this. It's just thrown straight up with only y direction, no horizontal. Or it can be 14 meter per second in the y direction, but the horizontal we just don't know yet. Either way, we have what we need. Minus g, 9.8, times what? T. Which is, we don't know that. That's what we need to find out. So it becomes negative 14 divided by negative 9.8. So it becomes approximately 1.43 seconds. Because 14 meter per second divided by meter per second squared, it becomes, units work out to become seconds. Matt's height is what? So the height, what you can do is, you can ignore this equation right over here, okay? This equation is a tad bit more advanced, and we'll be going over it later. But for right now, ignore it. The equation we're going to be using is one of the big 5, or the big 3 for projectile motion. YF is equal to y initial, which is 0, plus VI t. VI is what? 14 meter per second times time, which we know is 1.43, plus 1/2 AT squared, or minus 1/2 9.8 1.43 squared. If you plug all of this into your calculator, which I'm going to do right now, it should work out to become the same answer. So try and follow along with me. Yeah, so I get approximately 9.99999, which is, obviously I can round it up to 10. This formula over here, it's a bit of a shortcut, and I'll show you where we get this from later, okay? Because obviously I don't want you to just memorize these formulas. Or, you know what, let me just show you right now. You could skip this part of the video if it's not to your taste, but let me just show you where I got this from. Vi squared minus 2a, or minus 2g delta y, right? And then let me erase this. So this is one of the big 5 and big 3 for vertical motion. VIY, VFY. So if you know that VFY is 0, right? Because at the height, or the maximum height, the vertical velocity is 0. We know that VIY is just a velocity initial, right? Velocity initial squared minus 2g times what? Delta y. But since we start at 0, and if you end up at this height y, Delta y is just the maximum height, right? Because it's the maximum height minus 0. So it's just the maximum height. So I'll just write h here. We can just divide h is equal to negative vi squared over negative 2g. H is equal to vi squared over 2g. This, it comes straight from this equation, but if you want it as your own separate equation, you can. Okay? This is the height of a projectile motion. For y. For y. Maximum height reached for y. Okay. I'm hoping you wrote that down. So let's try some more problems. As always, more comprehensive problems will be released on artslearning.com and on different videos. Thrown up at 20 meters per second. So velocity y initial is 20 meters per second. Find t when it first reaches y is equal to 15 meters. So the line that would be around here. Use y is equal to vyit minus 1/2 gt squared. Okay, so they seem to have given us the equation. But over here, there would be a y initial, right? But why is there not a y initial? Because we started 0. So it's basically equal to 0 plus vyi initial, 20 meters per second, times t minus 1/2, 9.8 or 9.81, either one works, times t squared, which we still don't know. And all of that is equal to, well, we know the y, right? We're asking what time does it reach 15. So we know that this final y has to be 15. So then you can solve it like a quadratic equation. It's a bit complicated, but we can do it. So yeah, you first subtract 15 from both sides. You're left with negative 9.8 over 2 t squared plus 20t minus 15 is equal to 0. Now you can find the solutions for this equation. Right? If you can either graph this or you could use the quadratic formula. Right now I'm just gonna graph it because that's a bit easier. Okay. Now, once you solve this equation, you might get two solutions, okay? This is something you need to remember. Oftentimes, you can get two solutions for equations like these, and you need to know which one to use. The one you're going to use is going to be the one that makes more sense. If the two solutions, if one is negative over here, then you know that has to be positive, right? Because time is, well, it always has to be positive. You can't have negative time. So the answers are 1 and 3 seconds, right? I got two positive answers though, so this is good. But when it first reaches y is equal to 15 meters per second, and when is it first going to reach that? At 1 second. Pretty straightforward. Same throw, but find Vy at y equals 5 meters on the way down. Okay. All right. So Vy is equal to Vi, right? Minus Gt. Now, that comes from one of the big three for projectile motion, vertical motion. Now, I'm going to do 5 is equal to, or first let me write out the equation I'm going to use. Y final is equal to y initial plus Viyt plus, minus 1/2 gt squared. It could be plus, but that's only if you consider g as negative inherently. Or you could just write this, which is a bit more easier. So 5 is equal to yi is initial is 0 meters. VIY initial is 20 meters per second, like we saw last time. T I don't know yet. Minus 1/2 9.81 t squared, which I don't know yet. So same thing I'm going to plug into my calculator. Negative 9.81 over 2t squared plus 20t minus 5. I'm going to check where this equals 0. Okay. Now this time I'm not getting very nice points, but that's fine. So now I'm going to look at this and I'm going to take both the points. So you can, if you have a TI-84, you can follow along with me and click intersect the y-axis and you can find the zeros of the function. So here left bound, here right bound. So I got 0.267, but that's the first time, right? I want the second time. So what's the second time it intersects, or what's the second 0? It's going to be this to the left near 4, which is 3.814 seconds. Now I'm just going to plug this in here. So Vy final is equal to Vi, or in this case, that's just 20 meters per second, minus 9.81 or 9.81 times 3.814 squared. Or sorry, no squared. This one is just regular. And then plug that in. You get negative 17.415 meter per second, which makes sense, right? It should be going downward and the velocity should be negative. Now there is another way you could have done it. You could have probably used the Vf squared is equal to Vy initial squared minus 2g delta y. But that one is a bit more like, it's just more plug and chug. This time I want to show you how you can use two projectile motions to find the same thing. Okay? Now last one. A ball lands with Vy is equal to negative 24 meter per second after being thrown straight up. Find its initial Vyi. Okay. Negative 24 meter per second is equal to Vyi minus 9.81 times t. Let me erase this. Okay. Problem is we have two variables here, right? And we want to find one of them. So the other way, I could also use a double equation, right? I could use the other equation. Vf squared, or in this case, negative 24 squared, is equal to Vi squared minus 2a, or in this case, 9.81, delta y. We know delta y is going to be 0, right? Because you understand that when it's falling, right before it hits the ground, it basically is at the same position, right? It starts over here and it ends over here. So it's basically 0. And then it just becomes negative 24 squared is equal to Vi squared. So that then in that case, it would be positive 24 Vi, because Vi initial has to be positive, right? Then Vy final can be negative, which makes sense because this final has to be the opposite of this initial. Now that's it. And if you have any questions or if you want more on this topic, then you can look at my other videos regarding projectile motion as well as vectors and the big 5 of kinematics. Otherwise, feel free to give me a like and subscribe if you believe I helped you, and take a look at my other content or take a look at my website, artslearning.com. for additional help. You're welcome.